looking at 11.7, and we're going to look at number 10. Let me just click on it. Okay. On this one, you're asked to consider the series, the sum as n goes from 2 to infinity of x to the n over n times the ln of n to the 12th, right? And they want to find the series radius and interval of convergence, and then when does it converge absolutely for what values of x? Is it conditional, etc.? Okay. We should probably use, the first thing we want to do is use, you can either use the ratio or the root test to work these problems. What we want to do is look at the ratio test to get the interval of convergence. And remember that if the ratio test is less than 1, then the series will converge, right? So we want to find values for x where it's less than 1. And so we want to look at the limit as n goes to infinity of a sub n plus 1 over a sub n. And we want to see where this is less than 1. Okay, so we'll look at the limit as n goes to infinity, I mean, you do the absolute value, of x to the n plus 1 over n plus 1 times the ln of n plus 1 to the 12th, all over x to the n over n times the ln of n to the 12th. Which you can write horizontally then, the limit as n goes to infinity of x to the n plus 1 over n plus 1 times the ln of n plus 1 to the 12th times n times the ln of n to the 12th over x to the n. Okay, and so that's just going to leave an x in the numerator. You're going to have x over, and then we have this, we have an n and an n plus 1, and then we have an ln of n to the 12th over an ln of n plus 1 to the 12th. And you can, look at that, like, personally. I mean, you could use L'Hopital's rule on that, but you can kind of just think of it as a race. The ln of n compared to the ln of n plus 1, as n goes to infinity, they're basically going to be the same thing. Just like n and n plus 1 are basically going to be the same thing as n goes to infinity. So you're actually just going to get, of course, it's always absolute value. So in the end, you just get the absolute value of x, whatever x is, because that's all just going to reduce down to 1. Okay, and so this ratio then, this absolute value of x, has to be less than 1 to get your radius of convergence. So this is going to be -1 to x, which -1 is less than x, which is less than 1. That's your interval of convergence, but you have to still test your endpoints to see what happens at each of the endpoints. So you'll put -1 in and 1 in to test the endpoints. So we'll have -1 to the n over 1 -1 times the ln of -1, that's some trouble there, to the 12th, right? where n goes, no, I'm sorry, only the x is, hello, only the x. So it's negative 1 to the n over n times the ln of n to the 12th. So we want to try and figure out whether that converges or diverges. Do you have any idea? You think it diverges?
The negative 1 at the end is just going to keep going back and forth, and 1 and negative 1. Bottom's going to just.
So it's an alternating series, right? When you say the negative 1 to the n makes it an alternating series. So all we really need is for that denominator to go to 0 and for each term to be smaller, which we have. So I would actually say that this is a, this is a, this converges by the alternating series test. Now, when you plug 1 in, you're going to have to think about it some more. 1 to the n over n to the ln of n to the 12th. And so that's going to be just 1 over n times ln n to the 12th. All right, and so trying to think, if you do, what can we do? We're going to get 1 if we do the ratio test. If we do the integral test, is the derivative of ln x is 1 over x, right? Okay. So if we consider the integral test, and we look at the integral from 2 to infinity of 1 over x ln x dx. If you let u equal ln x, then du is going to be 1 over x dx, right? Which is exactly what you have there. So this is going to be the integral from 2 to infinity of 1 over u du, right? And then this is going to be u squared over 2 from 2 to infinity, which is going to be the ln of x squared over 2 from 2 to infinity. And that's going to go to infinity, right? Mm-hmm. They're saying that this converges, but I'm just not seeing it. If I let u equal, no. Du is, golly. All right, this is u to the negative 1, right? What's the integral of u to the negative 1? This is ln. right? So this is ln u. I'm still going to get infinity, though, right? Because that's going to be the ln of x.
Your conference is scheduled to end in 2 minutes.
I'm asleep, I guess. I'm not seeing, they're saying this converges. I'm just not seeing that converge.
Before you start, can you consider like 1 over x times 1 over ln x? Because by themselves, they both diverge.
Yeah, but you don't really know. I don't think 1 over ln x. Have we proved that? Oh, you know what?
It's smaller than 1 over x.
This was to the 12th. Why did I lose mine to the 12th? I wonder if that helps. Yeah, that kind of helps. God. So this is u to the negative 12, right? du. So you add 1 to the exponent. I'm sorry. I'm asleep. You add 1 to the exponent, so this is going to be u to the negative 11 over negative 11. So this is evaluated from 2 to infinity. So this is negative 1 over 11 u to the 11th from 2 to infinity, which is negative 1 over 11 ln x from 2 to infinity. That is going to be equal to, that one's going to go to 0. It's going to be 1 over 11 ln 2, right?
Isn't it still just 11? ln x? Right?
Yes.
It doesn't make a difference.
No, it doesn't make a difference. But anyway, so, well, yeah, it doesn't make a difference. But anyway, so the series
Your conference is now over. Goodbye.
converges. Sorry. Ooh. Miss Brooks is asleep. Okay, so we can actually grab, I guess, so we can do, it converges on both sides. So we're going to say our interval of convergence is from negative 1 to 1, including the endpoints. Okay, so I got that, yay. The radius of convergence then is, you just compute half the distance of the interval. So in this case, the radius of convergence is half the distance of the interval of convergence, which is, okay, the interval is from negative 1 to 1, so the distance 1 minus negative 1 divided by 2, right? So that's just going to be 1 is equal to the radius of convergence. The distance is 2, and then you take half of it. So that's 1. Okay. And then it actually converges, then it asks for what values of x does it converge absolutely. And so all we really have to worry about then is our endpoints, because we know that the interval is going to converge absolutely on our interval. On this side, on the right-hand side, when we used 1, we got the series to converge. And it turns out that we just used the alternating series for the negative 1. But if we had done the absolute value, we would have had exactly what we had here. So this is actually going to converge absolutely on the interval, because we didn't have to use the alternating, I mean, we didn't find it only to work for the alternating series tester. So it converges absolutely on the interval from -1 to 1. 2, 1. Check answer. Well done. All right. Now it says, it says, for what values of x does the series converge conditionally? Select the correct choice below. If necessary, fill in the box and complete your choice. The series does not converge conditionally. And so, okay, so that's it on that one. Where did you get stuck on that one? What, the integral test?
Yeah, I just didn't get exactly
Pardon?
how they were getting to it.
Say it again.
I just didn't get exactly how they were. I didn't get exactly how they were getting to it.
Yeah. I don't like their way that they did it in the view and example. They just said it is known. I'm like, oh, I didn't know that. You know, I had to verify it with the integral test, and even that I couldn't do very well because I couldn't remember what I was writing. But since it was to the 12th power, that was where it got good. I mean, obviously, if it had just been 1 over x ln x, that series diverged. I used the integral test to show that diverged. And so that's where I was messed up. But that wasn't the series I should have been considering, or the integral I should have been considering. I should have considered it to the 12th, ln x to the 12th. Actually, if it had been ln x to any power, like ln x squared, then you're good to go. Because you would do that little u substitution and you would get it to go to be 1 over the ln x. So by not putting that 12 there, I messed myself up. Sorry about that.